Hey everyone, lesson 2, exponents and logs. Okay, so today we're looking at solving exponential equations with a common base. Okay, this first question, the review, we're going to skip that, but for the ones on your assignment, basically what you want to do is get the bases all the same, 9, 27, 81, those could all be base 3, and then use your exponent laws after that. We are going to use this space for a different example at the end of this. So for now, let's go to here. Solving exponential equations with a common base. So basically an exponential equation is an equation in which the variable is in the exponent. So if you look at all these equations down here in example 1, take a look at where x is in the exponent on both sides here, okay? So our goal or our strategy here would be to write each side of the equation in the same base. So always be on the lookout for things that can be written as the same base, like 3 and 81. Okay, we should know now that 81 is 3 to the something, 27 is 3 to the something here, and root 3 could be 3 to some exponent as well. Okay, and then what you do is you try and get one term on either side. So only one base, okay, each side of the equation. So you have to have one thing equals another thing, and then if you manage to make the bases the same, whatever it might be, 3 and 3 or something, then the exponents would equal each other. So then you make the exponents equal to the other exponent. Okay, and once you do that, it's a simple equation to solve. Okay, let's try the first example. All right, solve the following exponential equations. Okay, so right away you'll notice we have one term on either side, so that's great. Notice the base, both base 5. So if this 5 to the 2x plus 3 equals 5 to the 7, therefore the exponents would have to equal each other. 2x plus 3 would have to equal 7 for this to be true. Then you just solve the equation like you would normally. Subtract 3 from both sides. You get 2x equals 4, divide both sides by 2, and you get x equals 2. Awesome. Okay, part B. Take a look at that one. 7 and 343. Now 343 is a pretty big number, but if the base over here is 7, likely 343 can be 7 to some exponent. So try it on your calculator. 7 to, well, we know 7 to the 2 is 49. Try 7 to the 3. Yeah, exactly. That's equal to 343. Notice how big the numbers get. So if you went like 7 to the 7, it would be a very large number. Okay, base is the same, therefore 3 dots like this means therefore x minus 2 would equal 3. Add 2 to both sides, and we get x equals 5. Woohoo! Okay, why don't you guys do the next, well, for sure do C, and give a try on D, and then we'll check back and see if we have the same answer. Okay, pause your video, please. Okay, on C, did everyone get negative 1/7 for x? Okay, let's just run through and make sure if you didn't, you got the find your mistake. So first of all, 81 is 3 to the 4, so we can scoop 81 out and put in 3 to the 4 because those are equivalent. Then we have power of a power happening on the right-hand side, so we simplify that by getting 12x. Now we have one power equals another power. The bases are equal, so therefore the exponents are equal. And then we solve the equation, subtract 5x, divide by 7, and we have our answer. Okay, on D, you'll notice 3, 27, and 3. Those can all be written as base 3. So we write 27 as 3 cubed. Now that root 3 actually can be written as a power as well. So let's think square roots. That's like saying there's a little 2 in there and there's a 1 here. So the exponent would be a fractional exponent, 3 to the 1 over 2. And there we go. Now do not drop the bases and make the exponents equal yet, because we have two things on the right hand side. We need to combine those to equal 1. So what's the rule of multiplying powers? We add the exponents. So 3 plus 1/2, which is going to be, we can write that as 3.5 for now. And then on the left-hand side, we still have 3 to the x. Now the bases are the same. We have one power equals another power, so therefore x would equal 3.5. The exponents equal each other. Oh, what did I write? Equals 3.5. There we go. All right, good. Let's look at the next page. Okay, example 2 is kind of a real-life application question. And we're going to do more of these actually later on, where the equations can't be solved by getting the bases the same, but this one can. So a bacterium triples every 6 days. Okay, nice to think about, right? The number of bacteria, N, so they're telling you what N is. That's important for later on when we have to write a sentence. present after x days, so x represents the number of days, is given by the formula n equals 3 to the x over 6. Okay, after how many days are there 243 bacteria? Okay, so they're giving us which variable? 243 bacteria, number of bacteria was n, so they're basically telling us that n is 243 in that equation. So what we can do is replace n in the equation with 243, and then they want after how many days, so that means we're trying to find x, because x was number of days. All right, so take a look at that equation. We want to try and get the basis the same, so I would assume that 243 could be 3 to some exponent. So try it out on your calculator, 3 to the 4, 3 to the 5, 3 to the 6, until you get the right one. And what did you find out? 3 to the 5. Good. Okay, so we changed 243 to 3 to the 5, not changing the equation, just writing it in a different way. Now we have one power equals another power. The bases are the same, so therefore the exponents would equal each other. 5 equals x over 6. Okay, so in that step, we're just simply making the exponents equal to each other. All right, so now to solve for x, we're going to multiply both sides by 6, and we would get x equals 30. Okay, so we'll write a little sentence here. After how many days are there that many bacteria? So I would write after 30 days, there are 243 bacteria. Lovely. Okay, good. All right, example 3. Solve the following exponential equations by converting each side to a common base. Okay, so same idea as the ones from example 1, except the equations are a little bit trickier. But the goal is the same. You want to get one power equals another power, and if the bases are the same, the exponents will equal each other. So it's all about the bases. Look at the bases of our powers. 27, 81. Okay, by now you're probably getting to know these numbers. These are both of base 3, so 27 is going to be replaced with 3 cubed. Okay, x minus 2 on the outside. I would put that in brackets to remind yourself that you'll have to distribute that later. 81 is going to be 3 to the 4. Okay. All right. Now you may notice here that we're still, here let's simplify this just a bit. We'll distribute these through 3x minus 6, and over here we'll still have that 1 on top, 1 over 3 to the 4x plus 12. Okay, so we're not quite there yet. You'll notice we have on the right-hand side 1 over. Well, that's not base 3 yet. That's 1 over something with base 3. So it's like that example from the last lesson. We're going to move that whole power into the numerator. If we do that, the exponent has to go negative. Okay, so we're doing that. 3x minus 6. Okay, so I'm going to multiply that negative through first. Okay, and yes, you could have done that in one step if you wanted, but what happens is people make the 4x negative, but not the 12, and then you get the question wrong. So it's maybe a good idea to do it in 2 steps. Negative, brackets around that, and then multiply through. Okay, so 1 power equals 1 power, base is the same, therefore the exponents would equal 3x minus 6 equals negative 4x minus 12. Okay, I would probably add 4x to both sides so that our x terms are positive. That'll get rid of that. And while we're at it, let's add 6 to the other side so the numbers are together. And we will have 7x equals negative 12 plus 6 is going to be negative 6. So x equals negative 6/7. Woohoo, okay. All right, next one. Looks intimidating, doesn't it? Okay, just focus in on the bases, okay, of your powers. So we have 125 over 216, that's the base of this power, and 6 over 5 on the right-hand side, that's the base of that one. 5, you'll notice, is kind of connected to 125, right? In fact, 125 we know is 5 to the exponent 3. Okay, now the numerator here is a 6, so what do you think 216 is probably going to be? Yeah, it's going to be 6 to the something. Since the numerator on this base was 5 to the 3, I'm thinking the denominator is going to be 6 to the 3. So check that on the calculator. 6 to the 3, that equals 216, right? Okay, good. Now we're going to rewrite this and then take another look at it. All right, So first of all, these both have 3's on them. So just like that lesson 1 example, we're going to bring that 3 outside so that it looks like this. Okay. And I'm just going to go ahead and multiply that. So that would be negative 3x over 4. You don't multiply the 4 by 3 because then you're multiplying by 3 over 3, which is just 1, not 3. Okay. All right. Do you see anything wrong with this right now? Okay, look at the bases. Yeah, one's the reciprocal of the other, right? How do I make, say, this one's 6 over 5? What do I need to do? I need to make the exponent the opposite sign. So if it was negative to begin with, I'm going to make it positive 3x over 4. Okay, and that's how I can reciprocal the base on my power. Again, never reciprocal your exponent. Ever, ever, ever. Never reciprocal the exponent. Okay, now the bases are the same. We have 1 power equals 1 power, so therefore the exponents, 3x plus 4 equals 3x minus 3. Okay, don't like that ugly fraction, so what are we going to do? We're going to multiply both sides by 4 just to make this a little easier to work with. So the 4's can go. We're left with 3x equals 12x minus 12. Remember to multiply the 4 through. All right, and then we just simplify that. And divide by 9. Whoa, what happened there? Okay, divide by 9, and we would have a reduced fraction of x equals 4/3. There we go. That should be your answer. All right. Now, remember I said leave that space blank. We're going to come back to it. I have an example I would like to do in that space. So let's go back to that first page. Okay, so we're not going to do this, but there's a question in your assignment that, and there's only one of them, and I think I would like to do an example so that when you hit that question, you'll know what to do, because it's a little bit different actually. So here's our example. It's 3 to the 2x minus 10, and then brackets 3 to the x, plus 9 equals 0. And basically the question says solve for x. Okay, now I'm going to make this a little neater. Older I get, the sloppier my handwriting gets. Okay, so take a look at that. So here's what we're going to do. You'll notice what's in the brackets here, right? 3 to the x looks sort of like what's in the first term, but not exactly. So here's our first step. We are going to rewrite this so it's 3 to the x with the 2 on the outside. Everybody okay with that? Really what I did was sort of unsimplify it, right? If power of a power, that would be equivalent to 2x, so I just brought the 2 out. Why did I do that? Because I wanted this 3 to the x in brackets, just like the other 3 to the x is in brackets. Okay, and then you're about to see that I'm not just crazy, I'm actually doing this for a reason. So what we're going to do is we're going to let, what's my favorite variable? M, okay, let m equals 3 to the x, and we're going to scoop 3 to the x out and put in m. I shouldn't be writing so big because we might run out of room here. Okay, so we have now m squared minus 10m plus 9 equals 0. And there we go, we have a quadratic equation. We are going to factor that. So m times m gives us m squared. Okay, multiplies to 9, adds to negative 10 would have to be negative 9 and negative 1. Branch each one off to equal 0, so m equals 9 and m equals 1. Now, replace m back with 3 to the x. Okay, and same thing here. So now we actually have 2 exponential equations where we want to get the bases the same. 3 to the x equals 9 and 3 to the x equals 1. So let's see if we can get the bases the same. 9, I know that to be 3 squared, right? So 3 to the x equals 3 squared, what does that mean about x? Therefore, x would equal 2. Good, that's one of our answers. Okay, this one here, 3 to the x equals 1. Let's see. How can I write 1 as 3 to some exponent? Well, yeah, that's special case 1, right? Remember, if I have anything to the 0 exponent, that equals 1. So by doing that, 3 to the x equals 3 to the 0 now. 3 to the 0 is still equal to 1. Therefore, x would equal 0. The exponents equal each other. Okay, cool. Okay, so this is sort of part 1 because we're going to do lesson 3 as part 2 of your assignment tonight. So good job on this stuff. Hope the homework on this lesson goes well, or the in-class work, I should say. And we'll take a look at lesson 2 in part 2. All right, we'll see you there.